Hi everyone. Today we are going to talk about numbers again. You really can't run away from numbers. You look around, you find numbers everywhere. So today we are going to do the unit Fun with Numbers. You can find this in your textbook as Unit 4. Let's talk about different types of numbers. What are whole numbers? Numbers starting from 0 are whole numbers, that is 0, 1, 2, 3 and so on. Numbers starting from 1 are called natural numbers, 1, 2, 3, 4 and so on. How about integers? Integers include negative numbers, 0 and positive numbers, minus 6, minus 5, minus 4, all the numbers 0, 1, 2, 3 and so on. Let's talk about odd numbers, 1, 3, 5, 7, 9 and so on. They are odd numbers. Even numbers are 2, 4, 6, 8 and so on. Even whole numbers include 0 as well. That is 0, 2, 4, 6, 8 and so on. Now let's talk about multiples and factors. What are multiples? 3 ones are 3, 3 twos are 6, 3 threes are 9, the table of 4, 4 ones are 4, 4 twos are 8, 4 threes are 12, the table of 5, 5 ones are 5, 5 twos are 10, 5 threes are 15. In this table, 3, 6 and 9, 3, 6 and 9 are the multiples of 3. What are the multiples of 4? 4, 8, 12 are the multiples of 4. What do you think are the multiples of 5? That's right. 5, 10 and 15 are multiples of 5. 3, 6, 9 are multiples of 3. But as you can see, we can have many more numbers. All the numbers in the 3 table are multiples of 3 and so on, even for 4, even for 5. So, if you take any number and multiply it with any natural number, the product becomes the multiple of that number. So, you take a number, you multiply it with any natural number. Natural numbers are 1, 2, 3, anything. Whatever product you get, that is the multiple of that number. Now let's try finding out the multiples of 8. Multiples of. What are the multiples of 8? Multiples of 8 are 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32 and so on. So the multiples of 8 are 8, 16, 24 and so on. 8, 16, 24 and so on. That's how you find the multiples of a given number. Now let's look at some of the facts about multiples. The first fact, every natural number is a multiple of 1. Fact 2, every number is a multiple of itself. We've seen it in the earlier example. 3 is a multiple of 3, 4 is a multiple of 4 and so on. How about fact 3? Multiple of a number is either equal to or greater than the number. We've seen in the multiple of 3, we see that the multiples of 3 are either equal to 3 or greater than 3. And the last fact, fact 4, a number has infinite number of multiples. So the multiples of 3 are 3, 6, 9, 12, 15, 18, and it goes on. Now let's learn about factors. I'm going to write a few multiplication equations. Have a look at it. 1, 24 are 24. 2, 12 are 24. 3, 8 are 24. 4, 6 are 24. This is the first group. The second group is 1, 18s are 18. 2, 9s are 18. 3, 6 are 18. So if you look at the above equations, we can say that the factors of 24, are, I'm going to circle the factors so that you will know what are the factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. I'm going to write it down. 1, 2, 3, 4, 6, 8, 12, 24. These are the factors of 24. How about the factors of 18? What are the factors of 18? Factors of 18. I'm going to circle it. 1, 2, 3, 6, 9, and 18. 1, 2, 3, 6, 9, and 18. Are you getting the picture? So when you divide 24 by 2, we get 2 1s are 2, 0, 2 2s are 4, 0. So you get the remainder as 0. So when 24 is divided by 2 or 3 or 4 or 6 or 8, the remainder is always 0. That's why we can say that 1, 2, 3, 4, 6, 8, 12, and 24 are factors of 24. The remainder has to be 0. Now let me ask you a question. Is 9 a factor of 24? How do we check? We just have to see if the remainder is 0 or not. So let's do that. Let's divide 24 with 9. 9 2s are 18. If you remove this, 24 minus 18 is 6. So you see the remainder is not 0. It is 6. So 9 is not a factor of 24. Now let's look at some of the facts about factors. Number 1. 1 is a factor of every natural number. We've seen in the example above how 1 is a factor of every natural number. Fact 2. A factor of a number is either equal to or less than the number. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So all the factors are either equal to or less than the number. Fact 3. Every number has a definite number of factors. In multiples, we saw that the multiples are infinite, but the factors are definite. For example, the factors of 18 are 1, 2, 3, 6, 9, and 18. You can count them. What are the factors of 25? 1, 5, and 25. Can you tell me what is the smallest factor in that? That's right, 1 is the smallest factor. What about the largest factor? 25. That's right. So we can always find the smallest and largest factor. Let's learn about prime and composite numbers. If a number is divisible only by 1 and itself, that number is called a prime number. Numbers that are not prime are called composite numbers. Now, what is divisible? A number is divisible when it is divided and leaves no remainder. When the remainder is 0, you say that the number is divisible. Let's consider two numbers, 6 and 7. 6 divided by 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. 6 divided by 6 is 1. Let's do it for 7. 7 divided by 1 is 7. 7 divided by 2, it's not divisible by 2. 7 divided by 3 does not leave a remainder 0. 7 divided by 4, okay, 7 divided by 7 is 1. So we can say that 6 is divisible by 1, 2, 3 and 6. So 6 is a composite number. Whereas 7 is divisible only by 1 and 7. Therefore, 7 is a prime number. So, a prime number like 7 is divisible only by 1 and 7. Divisible only by 1 and the number itself. Every other number becomes a composite number. Let's see if 9 is a prime number. Is 9 a prime number? What do you think? Let's see. 9 divided by 1 is 9. 9 divided by 2 is, the remainder is not 0. How about 9 divided by 3? 3. 9 divided by 9 is 1. So 9 is not a prime number. Because we have 1, 9, but we also have 3. So 9 is a composite number. Let's look at these two tables. Both the tables have numbers on the left side and factors on the right side. In table 1, if you notice, all numbers have only two factors, 1 and itself. For example, look at number 5. The factors are 1 and 5. Number 13, the factors are 1 and 13. So those numbers in table 1 are called prime numbers. Let's look at table 2. The numbers there have more than two factors. For example, look at 9. The factors are 1, 3 and 9. How about 14? The factors are 1, 2, 7, 14. Since those numbers have more than two factors, they are called composite numbers. Very good. Let's learn a few facts about prime and composite numbers. If you observe the table, you will find that there is no number 1. So 1 is neither prime nor composite. That is your fact 1. How about fact 2? Notice both the tables. You will see that the smallest prime number is 2. 2 is also the only even prime number. Look at table 1, which has all the prime numbers 2, 3, 5, 7, 11 and so on. Only 2 is the even prime number. You also notice that no prime number ends with 2, 4, 6, 8 and 0. Another fact is any number ending in 5 is also not a prime number. That's because 5 will be a factor of such a number. So let's recap what we have learned so far. We learnt about different kinds of numbers: whole numbers, natural numbers, integers, even numbers, odd numbers, even whole numbers. Then we went into learning how to do factors and multiples. After that, we learnt about prime and composite numbers. Now let's talk about prime factorization. What is factorization? Writing a number as a product of two or more numbers is called factorization. For example, 12 can be written as 4 into 3 or 6 into 2. So, what is prime factorization? Writing a given number as a product of two or more prime numbers is called prime factorization. The same 12 can be written as 2 into 2 into 3, that is prime factorization. So, when you write 12 as 2 into 6, these are the factors. But when you write it as 2 into 2 into 3, these are the prime factors, because it's a product of prime numbers. 2 and 3 are prime numbers. Let's take another example. 24 can be written as 3 into 2 into 2 into 2. You see, these are the prime factors of 24. Let's learn about finding prime factors for a given number. How can we find them? There are two methods. The first method is a factor tree method. The second method is a division method. Let's talk about the first method, factor tree method. Look at the picture there. How do we find factors of 24? Remember, we are looking at finding prime factors of 24. So you need to write 24 first as a product of two numbers. One of those numbers have to be a prime number. So the first branch would be 3 into 8. So now you need to write 8 as the product of two numbers. You need to write the prime number in the circle. So what can it be? 2 into 4, that's right. 4 can be further written as a product of prime numbers. That is 2 into 2. Therefore, the prime factors of 24 are 3 into 2 into 2 into 2. The prime numbers are written in the circle, and those become the prime factors of the given number 24. Let's look at another example. 36. 36 can be written as 3 into 12. That's right. 12 can be further broken into 2 into 6. 2 is a prime number, so we are writing it in the circle. 6 can be written as a product of 2 and 3. Therefore, the prime factors of 36 are 2 into 2 into 3 into 3. This is how we use the factor tree method to find the prime factors of any given number. Now let's talk about the division method. This is the more common method we use to find prime factors. This is how we find the prime factor of a given number using division method. Division method. Let's find the prime factors of 36. So, if we divide 36 with 2, it becomes 18. 2 9s are 18. 3 3s are 9. 3 1s are 3. If you notice, you have to take the given number and divide it with prime numbers. Therefore, prime factors of 36 are 2 into 2 into 3 into 3 into 1. They are the prime factors of 36. Let's try another example. Let's find the prime factors of 24. 24, if you divide it by 2, you get 12. 2 6s are 12, 2 3s are 6, 3 1s are 3. So the prime factors of 24 are prime factors of 24 are, go ahead and tell me, 2 into 2 into 2 into 3 into 1. They are the prime factors. This is how you are able to find the prime factors of a given number using division method. Let's learn about exponential form. What is exponential form? 2 into 2 into 2 into 2 into 2. This is 2 is multiplied how many times? 1, 2, 3, 4, 5 times. How about 3 into 3 into 3? 3 is multiplied 3 times. So this kind of multiplication can be represented in another form called exponential form. So 2 into 2 into 2 into 2 can be written as 2 to the power of 5 or 2 raised to 5. 3 into 3 into 3 can be written as 3 to the power of 3 or 3 raised to 3. This is how you write it in exponential form. 2 to the power of 5, 3 to the power of 3. 2 and 3, they are called the base. Five and this 3 are called the exponents or index. So 2 and 3 are called the base and 5 and 3 are called the exponents or index. So if the exponent is 2, we say square. That's right. If the exponent is 3, we say cube. In other words, the exponent shows how many times the base has to be multiplied. In this case, the exponent is 3 and the base is 2. So the base has to be multiplied 3 times. What does this mean? 10 to the power of 6. 10 to the power of 6 means 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. 10 to the power of 7 would be 1 followed by 7 zeros. So this is how you write a number in its exponential form. Exponential form is useful especially when there are large numbers. If I have to ask you what is the distance between the Earth and the Sun, look at the picture. It's 150 million kilometers. If you have to write all the zeros in that number, it would take a lot of time. So the easy way to write it is 15 into 10 to the power of 7. That is 15 followed by 7 zeros. You can find this chapter, Fun with Numbers, in your textbook from page numbers 63 to 73. There are a lot of questions given there for you to practice and get better at what you have learned today. Happy learning. Bye.